Is my screen visible? Is my screen visible?
No, sir.
Now?
Blur, this is a blur.
Okay, I'm setting it. Hold on for a moment. I hope it is visible now. Is it?
Yes, sir.
Yes.
Yes,
So we
sir.
were talking about the reversal of the order of the limits. Okay. In first case, let us take for an example, we have summation of k from 0 to 2 and summation it is of a raised to k. So you will get it as a raised to 0 plus a raised to 1 plus a raised to 2. When you solve this, you will get 1 plus a square. Now if I reverse the summation limits and if I put it as summation from k equals to 2 to 0 of a raised to k, what do you get? You will get a raised to 2 plus a raised to 1 plus a raised to 0. Okay, so this is a square plus a plus 1. But this and these two are exactly same. Okay, in summation, even if you reverse the order of summation, the summation still remains the same. Okay, the summation of the equation, the summation of the entity still remains the same. So instead of this equation number 2, even if I reverse the order and the limits of summation, the summation would still give me the same results. So I am writing n equals to minus infinity to infinity x of n minus m h of n. Okay, so let this be your equation number 3. Right? So now in equation number 3, we all know that m was any random variable that we had chosen. Okay, it was any dummy variable. So now this dummy variable, let us substitute it by k. Okay, so I can substituting dummy variable m by k. Okay, so what you will get when you're substituting this? Yes, we'll get y of n equals to summation, instead of m, I'm substituting it to be k now. So this is k equals to minus infinity to infinity x of n minus k h of k. Okay, now if you observe this particular equation carefully, you will come to know that this is nothing but y of n equals to summation k equals to minus infinity to infinity. This is h of k into x of n minus k. Okay, I've just simply changed the order of the sequences. Okay, now this is the folded and delayed sequence, whereas x of k is the original sequence. So this can be written as h of n convolved with x of n. Okay, so we have started with x of n convolved with h of n, and we have come to a conclusion that h of n convolved with x of n. But h of n convolved with x of n is also giving you y of n, and x of n convolved with h of n was also giving you y of n. So that means that y of n is equals to x of n convolved with h of n, and this is same as h of n convolved with x of n. This means that the linear convolution is commutative. Okay, so here we have proved that, and the reason for proving this is, by solving certain numericals, you will be given two sequences. One of the sequences will be very tricky to obtain, but the other sequence can be very easy. Let us say the other sequence is a unit impulse function. Okay, it is a unit step function for that matter. Let us take it is a unit step function. Now it is very easy to fold and delay the unit step function when compared to that of a certain other complex function. Okay, but we all know that a linear convolution is commutative. So when you feel that one of the two sequences is easy, then whatever the easier sequence is, you can fold it and you can delay it, because folding and delaying of the other complex sequence is a bit difficult, but folding and delaying of a very simple sequence like that of a unit step function is very simple. So it is a choice now which sequence is to be folded and which sequence is to be delayed. Okay, so whatever the easier sequence is, the easier sequence we will be folding and delaying, and the other tricky sequence we will keep it as it is. Okay, so that is the actual benefit of this linear convolution being commutative. I hope you have got this proof. Did you understand this proof of linear convolution being commutative, everyone? Yes, did you understand this? Tell me.
Yes.
Okay. See, make sure that from the next lecture you do not join at least 5 minutes after the lecture has started. Okay, so you should not join more than 5 minutes after the lecture has been started. You should join at least before 11:05. Okay, there are so many people waiting in the lobby. Make sure that you join before 11:05. I'm letting you in. I'm letting you inside today, but from next lecture onwards, you people will be kept waiting in the lobby, and I'll not be admitting you, because it has been observed by some authorities that people are joining at 11:20, 11:30 for all lectures. So it has to be seen that you people are joining the lecture well within the time, and you people are into the lecture, attending the complete duration of the lecture, and then you are leaving it once the lecture has been finished. Okay, you should ensure that you people are joining at 11:05, at least at 11:05, not further than that, and you people stay in the meeting for the entire duration of the lecture. Okay, make this a habit from the next lecture onwards, because you people will be kept waiting in the lobby and you will not be allowed to get inside the meeting. Okay, tell me a quick feedback whether you have understood this proof. If you have understood, you can type yes in the chat box. Let me know how many of you have understood this. Okay. Okay, now we shall solve some numericals on this. Obtain linear convolution of two discrete time signals, and the two discrete time signals which are given are as obtain linear convolution of the given sequences. Okay, we have been given some discrete sequence. One of it is x of n. This is equals to u of n, and h of n is the other sequence, and this is equals to a raised to n u of n, where a is less than 1. Okay, where a is less than 1. So try to solve this. I give you a time of around 4 to 5 minutes. You can obtain the convolution of these two sequences. It is pretty simple. One of the given sequences is simply unit step, and the other one is a raised to n multiplied with u of n. I hope you are solving this. Are you? Are you solving this? Everyone? अरे बोला करो. Are you solving this? Yes or no? Do you want me to solve? Do you want me to solve? अरे बोला करो. सॉल्व कर रहे हो क्या?
Sir.
Okay. Okay, let me solve this. See, you have been given two sequences. One is x of n, and that x of n is nothing but a unit step function u of n. Okay, and the other sequence is h of n, and this h of n is equals to a raised to n u of n, which means it is a multiplication of an exponential signal a raised to n with unit step function. Okay, and it has been given that the magnitude of a is less than 1. Okay, now see, we all know that a raised to n is an exponential signal, and this signal is multiplied with u of n, but u of n is a unit step sequence which is present only for the positive values of n. Okay, for the 0th value of n and for the positive values of n, and it is absent for the negative values of n. Okay, so what does this mean? So what does this mean? This means that your exponential sequence a raised to n will now be present only for the positive values, because this exponential signal, when it is multiplied with u of n, which is nothing but a magnitude of 1 only for the positive values of n, will give you a signal only for the positive values. Okay, a raised to n is an exponential signal. When this signal is multiplied with u of n, you will get the output only for the positive values. Why? Because u of n is 0 for the negative values. When 0 is multiplied with a of n, you will get 0. Okay, but something is multiplied with a of n on the positive side, you will get that particular something. So that is why this will be a exponential signal only for the positive axis. Okay, which means only for the positive n values of n, positive values of n. Okay, and why is it a declining graph? Because a is less than 1. Okay, a is less than 1. Okay, what does a is less than 1 means? Okay, if you substitute this, this is n equals to 0, this is 1, this is 2, and so on up to n. When you're substituting 0 in place of n, you will get a raised to 0 equals to 1. So this magnitude is 1. Okay, but we all know that a is less than 1. So let a equals to 0.8 for that matter. Okay, 0.8 raised to 0, anything raised to 0 is 1. So this we are getting 1. Now 0.8 raised to 1 is equals to 0.8. So this is less than 1. So let this be 0.8. 0.8 raised to suppose 2. What is it? It is 0.64, and 0.64 is less than 0.8. So for the subsequent values of n, you will get a raised to n to be lesser than the previous value. Thus, this will be a decreasing exponential. I hope you have got this. Is it? Did you get this?
Yes, sir.
Okay. Now see, since a raised to n is multiplied by u of n, a of n, a raised to n is present only for positive values of n. Okay, let me make a note here. Since a raised to n is multiplied with u of n, a raised to n will be present only for positive and 0 value of n. Okay, now out of these two sequences, which is a simple sequence? Which is a simple sequence?
U of n.
U of n. Definitely u of n is a simple sequence. So it is very easy to fold and delay u of n rather than folding and delaying a raised to n. Okay, so that is why we will treat this sequence as h of n, and we will treat this sequence as x of n. Okay, since we have studied that linear convolution is a commutative property, we can delay x of k and we can keep h of k as it is. Okay, so what we will do now, we will write y of n is equals to k from minus infinity to infinity. I will keep x of k as it is.
Sir, screen freeze झाली.
The screen is not visible.
Freeze झालेली आहे.
Okay. I hope now it is visible.
Yes, sir.
Yes. So we all know that linear convolution is commutative. What does it mean? It means instead of delaying and folding h of n, I can delay and fold x of n, and I can keep h of k as it is. So here what I will do is I will keep h of n, that is h of k as it is, and I will delay and fold x of n. So what does my convolution become? It will be y of n equals to summation k from minus infinity to infinity, and the delayed signal will now be x of n minus k. It will be x of k. Is it visible? Is it
No, sir.
visible?
Blur दिसत आहे.
Okay. Yes. It is visible now, I guess.
Yes, sir.
Now? Yes. Okay. Okay. So we have used the commutative property of convolution, and we have kept h of k as it is, and we have delayed x of n. Okay. Right. So what will be y of 0? Y of 0 will be substituting n equals to 0 in this particular equation. Okay, let this be equation number 1. So substituting n equals to 0 in this particular equation, you will get y of 0, and this will be equals to what? Okay, a raised to 0. Why am I writing a raised to 0? What is my h of k? H of k is a raised to n. Okay, a raised to n. So I can write it as a raised to n, and then I can substitute the values of n from 0 to infinity. Okay, but I am not writing a raised to n into u of n. Why? Because already I have taken an account of this u of n, and this multiplication with u of n only means that a of n is present for positive and 0 value of n. There is no other meaning. Okay, because u of n is simply a unit step function with magnitude of 1. It is not actually changing the magnitude of a raised to n. It is only changing the limits of this particular function from 0 to n. Okay, for that matter, let me make it very clear. So this will be y of n equals to k from 0 to infinity now, because multiplication with u of n will give you only these signals for 0 and positive values. So this is x of k, h of k, x of n minus k. Okay, now let us substitute one by one the values of n. First, if n is equals to 0, you will get y of 0, and y of 0 will be h of k is your a raised to n, a raised to 0. Okay, x of n minus k, x of n minus k. But what is x of n, or what is x of k? X of k is u of n. Okay, x of k is u of n. So it is u of n minus k. Okay, it is u of n minus k, and for the first place we are substituting k equals to 0. So a raised to 0 and u raised to n minus 0. What is n? N is 0, so it is u of 0. Okay, this we have already seen in analytical method. I am solving this convolution using analytical method, and in the previous class I have given you an equation of solving this. Okay, plus now substitute k equals to 1, so you will get a raised to 1, which is nothing but a, and x of n minus k. Okay, in place of k now it is 1. So what is n? N is 0, so 0 minus 1, so it is u of minus 1, plus a square u of n minus 2, plus a cube u of n minus 3, and so on. Okay, so y of 0 will be equals to, what is a raised to 0? A raised to 0 is 1. 1 multiplied with u of 0, you will get u of 0, plus a raised to, this is a into u of minus 1. Okay, so this is a into u of minus 1, plus this is a square into u of minus 2. Why? Because n is equals to 0. We are obtaining y of 0, plus a cube u of minus 3, and so on. I hope you are getting this. Are you getting this? Are you getting this? Yes or no?
Yes, sir.
Yes. Okay. Now see, y of 0 is equals to, what is u of 0? What is u of 0? Unit
1.
step function at u of 0. At unit step function at 0 is 1, plus a into, what is u of minus 1? What is u of minus 1?
0.
It is 0. Okay, because unit step function u of n is only present for 0 and positive values. It is 0 for negative values. So this will be a square into 0 plus so on. So y of 0 will only be equals to 1. Okay. Similarly, now we will try to find y of 1. What will be y of 1? Y of 1 will be a raised to 0. Why? Because I will need to substitute the values of k from 0 to infinity in every case. So this is a raised to 0. Okay. What is h of k? H of k is a raised to k, and in place of k I have substituted now 0. So this becomes a raised to 0. This is multiplied with u of n minus k. Okay, what is n? N in this case is 1 minus k. What is k in this case? I have considered 0, plus a raised to 1 u of n minus k. Now n is 1, so 1 minus k is 1 in this case, plus a square u of n minus k. N is 1, so this is 1 minus k. K for this time it is 2. Okay, plus so on. Okay, so what you will get? Y of 1 is equals to a raised to 0 is 1. So this is 1 into u of 1 minus 0 is u of 1, plus this is a raised to 1 is a. U of 1 minus 1 is 0, plus a square. Okay, this is u of 1 minus 2 is minus 1, and so on. So if you observe this carefully, you will get this as u of 1 plus a into u of 0 plus u of minus 1, u of minus 2, and so on will be 0. So these all terms will be 0. So you will get y of 1 is equals to u of 1 is, what is u of 1? U of 1 is 1 plus a into u of 0. A into u of 0 is 1. So a into 1. So you get y of 1 equals to 1 plus a. Is this clear? Is this clear, everyone?
Yes, sir.
Tell me. Yeah. Okay. Similarly, you can find y of 2, and if you solve for y of 2, you will get y of 2 is equals to 1 plus a square. Okay, you can check this. Similarly, if you keep on solving this for the nth sample, you will get y of n equals to 1 plus a square. This will continue so on up to a raised to n. Okay, this will be your y of n. Okay, but now how to solve this expression? How to solve this 1 plus a plus so on up to a raised to n? Let us, for that matter, generalize this thing. Y of n is nothing but summation k from 0 to n a raised to k. Okay, if you substitute in place of k 0 to n, you will get this same expression. So I have just taken a generalized expression of this and I have written it in terms of summation. Okay. Now to this summation, we will try to use a standard equation. So the standard equation is using standard equation of summation. If you have summation n equals to lower limit as n1 and higher limit as n2 and summation of suppose a raised to n, then this summation is given by a raised to lower limit n1 minus a raised to higher limit plus 1. So this is n2 plus 1 divided by 1 minus a. Okay. This is true for a not equal to 1. Okay. And if a is equals to 1, then this particular summation gives you a result of n2 minus n1 plus 1. This is for a equals to 1. This is a standard mathematical expression for summation a raised to k. And when two of the limits are n1 and n2. Okay. Now in this case, in this particular question, you can see that n1 is equals to 0 and n2 is equals to what? N2 is equals to n. Okay, where did I take these values from? I've taken the values from here. You can see that n1 is nothing but 0 and n2, which is the higher limit, is nothing but n. Okay. Now substituting this in this particular standard equation, let us call it as A. Substituting these limits in the standard equation, you will get y of n equals to this summation, which is equals to a raised to 0 minus a raised to higher limit is n plus 1 upon 1 minus a. Why? Because a is not equal to 1. This is already given in the question that a is less than 1. When a is less than 1, it simply means that a is not equal to 1. Okay, right. So when you solve this, you will get y of n equals to 1 minus a raised to n plus 1 upon 1 minus a. So this is your actual result of the convolution. Have you all understood this, everyone? Have you all understood this? Yes or no?
Yes. Yes, sir.
Tell me if there is anyone who hasn't understood. Please type no in the chat box if there is anyone who hasn't understood, and then we'll move to the second problem. There is one more problem on similar lines. I will write the problem and you can take it as homework. Try to solve it. Okay, you have ample amount of time now. You all people are at your homes now, so you have enough time to solve more number of numericals and to practice more problems of this particular subject, because this is relatively numerical based subject when compared to other subjects. So let me write a question here. Pretty similar to what we have solved earlier. So use discrete convolution. Someone's microphone is unmuted. Use discrete convolution to find the response to the input x of n equals to a raised to n u of n of the LTI system with impulse response h of n equals to b raised to n u of n. So you simply have to obtain the convolution of x of n with h of n. Okay, so it means you have been given x of n is equals to a raised to n u of n, and you have been given h of n equals to b raised to n u of n. Okay, you need to find y of n. You need to find y of n. So take it as your homework and you can solve this at your homes. Okay, we'll switch to next problem now. Can you solve this? Tell me, can you solve this? Pretty similar to what we have solved here, and you also will need to use the same standard summation formula. Summation of a raised to n, limits n equals to n1 to n2. This will give you a raised to n1 minus a raised to n2 plus 1 by 1 minus a. In place of a, here you will have a by b. Okay. Can you solve this? Or do you want me to solve? Let me solve this. So this is x of k. X of k is a raised to k, u of k. This is h of k. H of k is nothing but b raised to k, u of k. Okay, and we know that y of n is summation k from minus infinity to infinity x of k into h of n minus k. Okay, what is this? This is a convolution formula. Okay, this is your convolution formula. Now, what is h of n minus k? What is h of n minus k? h of n minus k is nothing but wherever there is k, substitute it with n minus k. So you will get b raised to n minus k u of n minus k. Okay, so therefore you will get y of n equals to summation k from minus infinity to infinity a raised to k uk into b raised to n minus k u of n minus k. Okay, so simplifying this further, you will get y of n equals to summation k from minus infinity to infinity a raised to k. I will take this b raised to n minus k here and u of k into u of n minus k. Okay, what I will do now is I will try to see as to what this particular sequence gives me. Okay, because we all know that this is u of k is a unit step function. U of n minus k is delayed. Okay, delayed and folded and delayed unit step function. So naturally, if it is unit step function, the magnitude is 1. It will not change the magnitude of the original sequence. It will simply change the limits of this particular sequence, okay, of the original sequence. When are you going to tell me that the screen has gone off?
Yes, sir. Screen is not visible.
When are you going to tell me this? Okay, right. So this u of k into u of n minus k, both are unit step functions. One is the original unit step, the other one is folded and delayed. But we all know that even if it is folded and delayed, the magnitude still is 1. So this will not change. This particular multiplication of unit step with delayed unit step will not actually change the magnitude of this original function. Okay, this will only change the limits of k. So we will try to see as to how this happens. I will graphically try to show you. Okay, I'll first draw u of k. This is u of k, and u of k is this sequence. Okay, this is 0, and so on. We will get it up to k. Okay, this is u of k. Now, what I will do is I will try to obtain u of minus k. What is u of minus k? U of minus k is nothing but the mirror image of this. So you will get this. Okay, you will get this. This will extend from minus infinity. This will go up to plus infinity. For that matter, in this case, it is up to k. Okay. Now, when this folded is delayed, what do you get? When this folded is delayed by suppose k samples. Okay. So what do you get? You will get it as this will be shifted towards right, somewhat towards right. So you will get this. Okay. You will get this, and this will keep on continuing. Okay. So when this u of k is multiplied with u of n minus k, what do you get it as a result? What do you get it as a result? You can see that what result you are getting? You are getting this on a positive axis. Okay? You are getting this on a positive axis, and this will keep on continuing. So actually, this is not changing the magnitude of the original function. It is only changing the limits, and the new limits are now from 0 to the positive axis. Okay, that is up to n. Why? Because this has been delayed by how many sequences? N sequences. Okay, this was from minus infinity. This when you had folded, this was from minus infinity for that matter. Here in this case, it was minus k. Okay, so this minus k is now delayed by how many samples? By n number of samples. So you will get here up to n. Is it understood? Is it understood? Everyone?
Yes, sir.
Yes. So this is actually not changing the magnitude of this function. It is only changing the limits. Okay. So how does it change the limits now? Now you will get y of n equals to summation from k equals to 0 to n a raised to k b raised to n minus k. Okay. I'm not writing here this function now because this is nothing but magnitude of 1. And I've already taken the effect of this particular multiplication that the limits have been changed now. Thus, I am getting y of n equals to summation k equals to 0 to n a raised to k b raised to n into b raised to minus k. Is it okay? So this further can be simplified like summation k from 0 to n a raised to k by b raised to n into b raised to n by b raised to k. Okay. So what I can further do is I can take b raised to n outside, because b is not actually a function of summation, and I can write inside the summation k equals to 0 to n a raised to k by b raised to k. This is equals to b raised to n summation from k equals to 0 to n a by b raised to k. Okay, a by b raised to k. But we all know that summation of k n from n equal to n1 to n2 of any variable a raised to n is equals to what? A raised to n1 minus a raised to n2 plus 1 upon 1 minus a. This is when a is not equal to 1. Okay, and it is equal to n2 minus n1 plus 1 when you have a equal to 1. But we do not have a equal to 1 now. That is why we have to use this particular output. Okay, so here in place of a you have a by b. Okay, so here in place of a you have a by b. So I will write n1 is equal to 0 in this case. You can see n1 is equals to 0, n2 is equals to n, and you have a equals to a by b. Okay, so substituting this n1, n2 and a in this particular equation, in this particular standard equation, what do you get? You get y of n equals to b raised to n as it is outside, and the output of this summation is, what is it? A raised to n1. So what is it? A by b raised to 0 minus a by b raised to n plus 1 upon 1 minus a. What is a? A in this case is a by b. Okay, this is here. This is what you get here. When you further simplify this, what do you get? Y of n is equals to 1 minus a by b raised to n plus 1 upon 1 minus a by b. This is your actual convolution output. Have you all understood this particular problem? Have you all understood this problem?
Yes, sir.
In exam, you need not draw these graphs. Okay, this was only to explain you that when a unit step function is folded, you will get the values from minus k to 0. And when it is delayed by n samples, only the limit will be changed from 0 to n. In the output, you will get the sequence from 0th value up to the nth value. So only the limits will be changed. That is why, just for the sake of explanation, I have drawn these graphs. If you need not draw these graphs in your examination, if you can, from the look of the question, if you can understand that the limits have been changed and nothing else has happened, you need not draw this in your examination. Okay, this is only for the sake of explanation so that you people can understand this, right? Okay, so I'll give you one more problem for homework. Since this problem I've solved it here, the other one is very simple problem. Try to solve this and obtain the results. I'll ask you in the next class, okay, in the tomorrow's class. And then tomorrow we'll discuss about correlation. Firstly, we'll discuss about deconvolution, and then we'll talk about autocorrelation and cross correlation, which are nothing but the types of correlations. Take it this problem as homework. You have x of n equals to 1, 0, and 2. X of n is equals to 1 for minus 2, 0, and 1. It is equals to 0 elsewhere, and it is equals to 2 for n equals to minus 1. Okay, and the other sequence that is given to you is h of n. This is equals to del of n minus del of n minus 1 plus del of n minus 4 plus del of n minus 6. This is what we have. Try to solve this. So what you will get as x of n? You will get x of n is equals to see, at 0th sample you have value of 1. At 1 you have, at 1 what do you have? Yes, at 1 you have 1. Okay, so but you also have minus 1. Okay, so for I'll start from the negative most. I'll start from the left most. So you can see for minus 2, it is 1. For minus 1 it is 2. Okay, for 0 it is 1. So this is your 0th sample. Actually for 1 it is 1 and it is 0 for all other values, which means for the all other positive values this sequence has to be 0.
Sir, please झालेली screen.
Sorry, screen has gone off. Okay. Yeah, this is the question you have. You will get x of n something like this, and h of n is what? What is h of n? What is impulse del of n? This is 1. Okay, so the first sample is 1. Second sample is minus of del of n minus 1. Okay, so this is minus 1. Then you have n minus 4 plus del of n minus 4. Okay, so what is it? What is it? Directly the fourth one. Okay, so this is the 0th, this is the first, second, third is 0, and the fourth one is 1. Okay, and then fifth one is 0, sixth one is 1. Okay, this is the interpretation of this data. Have you understood this? Have you understood this?
Yes, sir.
Yes. So try to obtain the convolution of these two sequences. It is pretty simple, and I'll ask you the output of this in the next class. So I'll stop here for today. If you have any questions, you can stay put and you can type your questions in the chat box, or you can unmute and ask me. Otherwise, you can leave this meeting and join your another scheduled lecture. Okay, have a good day. Thank you for your patient listening.